Welcome. Autodesk Subscription Advantage Packs deliver tools that make an impact. In this video, an Autodesk technical specialist will give you a brief overview of the Subscription Advantage Pack for Autodesk 3ds Max and 3ds Max Design 2011, an exciting new set of tools that's now available exclusively to Autodesk subscription customers. If your Autodesk 3ds Max or 3ds Max Design software is on subscription, you can download your Subscription Advantage Pack now from within your product, or download it from the Autodesk Subscription Center. Let's take a look at the Subscription Advantage Pack for Autodesk 3ds Max and 3ds Max Design 2011 in action, and see how it can make an impact on the work you do.
Bringing your designs to life has never been easier than with the Advantage Pack for 3ds Max and 3ds Max Design 2011 using the newly integrated IRA Rendering technology from Mental Images. You will be able to generate physically accurate renderings without having to adjust and guess at any of the rendering settings. Let's use this condo space as an example. To help you understand the difference between IRA and other renderer, we will first render the scene in MentalRay. MentalRay, like most other rendering solutions, always requires a bit of guessing when it is time to fine-tune the rendering settings. The rendering window offers 5 different tabs, and it can be a bit daunting to figure out all the settings if you are not an experienced user. For example, to achieve a high-resolution result for this interior space, I first need to go to the Indirect Illumination tab and increase the amount of final gather bounces. I will also refine the final gather precision. Then, under the Renderer tab, I will increase the Soft Shadow Precision multiplier to 4, Glossy Reflection and Refraction multiplier to 3.0, and increase the sampling quality to minimum 1 and maximum 16. This scene is quite heavy at 3 million polygons, which will definitely slow down my MentalRay calculation. During the rendering process, the multiple MentalRay passes allow me to guess what the rendering result will be, but I need to wait till the end of the rendering to save a usable image. Since this rendering is using high-quality rendering settings, it took 2 hours, 40 minutes, and 48 seconds to render. The result is very promising, but there's still some area of darkness where I expect to have light entering the condo, which will leave me guessing what the setting I will need to refine in order to achieve better results. A technical expert will be able to quickly guess at the right settings for an optimal result, but many people do not have the desire or the time to learn the subtleties of the settings. Let's switch our rendering engine to IRA and compare the process. You will notice that the Rendering Setup window Common tab stays the same and that only one additional tab is available for IRA rendering settings. Basically, the only setting you need to adjust to have a physically accurate, photorealistic rendering is the rendering time. You can either enter the time by hour, minutes, and seconds, number of passes, or let it render until you decide to stop it. So the rendering time is always predictable. Let's render this image for 2 hours, 40 minutes, and 48 seconds, which is the same amount of time our MentalRay rendering took. The minute IRA starts rendering, you can start seeing results. The image gets slowly refined as the number of passes increase. Plus, at any time, you can pause or save an image of the rendering process. IRA progressively refines the image until the desired level of detail is achieved or the time limit you have entered is reached. You can now focus on applying physically accurate materials such as architecture and design material or Autodesk materials, photometric lights, and settings that truly resemble what you experience every day. IRA will give you a physical light calculation rendered image, not an approximation of the results. You can see here the image at about 25% completions, and already I can predict the final quality of the image. I will stop that render and show you both images that have been rendered for the same amount of time side by side. You can clearly see that the IRA render bounced the light accurately in this space, giving me an exact real-life result. Notice the soft shadow precision, the quality of the reflection here on the wood floor and in the ceiling paint. Fine details have been captured on object and the rendering result have photorealistic quality. Plus, the IRA rendering calculation is independent of the polygon count, so you can have a really heavy scene like this one without affecting your rendering time. With IRA, you will be able to understand how light enters your space, view soft reflections in your materials, capture fine details on objects, and even view your self-illuminated objects accurately. The effect of self-illuminated materials is clearly shown here in this scene. The luminance amount is accurately calculated, giving me predictable results, something that was, to this point, impossible to render accurately. Depth of field, which increased the photorealistic look of your images, is also part of the rendering calculation and does not add any rendering time. Another major milestone in the rendering revolution, IRA enables you to set up your scene, press render, and get predictable photoreal results without worrying about rendering settings, just like a point-and-shoot camera. IRA progressively refines the image until the desired level of detail is achieved, while letting you stay focused on your creative vision. IRA works with standard multi-core CPUs. However, you can significantly accelerate the rendering process with minimal investment by purchasing NVIDIA CUDA-enabled GPU hardware.
In this video, we're going to be taking a look at the PhysX engine from NVIDIA, now fully integrated into 3ds Max 2011. This PhysX engine helps create more compelling, dynamic, rigid body simulations directly within the 3ds Max viewport. It supports static, dynamic, and kinematic rigid bodies, also called ragdoll simulations, and multiple constraints. So I've pulled a couple of objects from our opening scene to show you just how easy it is to use PhysX on our objects. Before I do that though, let me switch over to wireframe view, and you can see that we've already broken up these objects into individual fragments using the Pro Cutter tool. So we've already done that step. And also notice these are exactly identical. This is on purpose, and I'll show you why in a few minutes. So to invoke PhysX, all we need to do is go to the PhysX menu and we're to choose Show UI. And we have a couple of different tools here, but we really only need to use the Show PhysX toolbar because we can access everything else that we need from there. Next thing we do is we just select the objects that we want to be part of the PhysX calculation. And from here, we choose Create Dynamic Rigid Body. We have three different types of solutions here, basically a dynamic rigid body, a kinetic rigid body, or a static rigid body. We'll talk about those in a second. So we'll choose Dynamic Rigid Body, and we press play, and it adds the default properties, and you can see it immediately begins showing us the simulation whenever we press play. Now, these are not keyframed yet. We haven't actually baked the keys in here yet. This is really just showing us the simulation. Now, let's go ahead and invoke the PhysX Tools menu. And from here, we can kind of adjust some things. We have control over whether we actually want gravity enabled, and that obviously changes the way our object works. You can see things just kind of float off into nowhere. We have the ability to have a ground plane. So if we turn off the ground plane, it'll just fall right through. And of course, we can control the amount of gravity and a couple of other parameters. So pretty straightforward, easy to use here. Changing properties is even easier, really. We use a material editor-like method for actually applying physical properties. It's called the Physical Material Editor, and you can see we have a couple of materials already applied. What I'm going to do is, before we start changing these around, I'm going to go ahead and select this object, and I'm going to create a dynamic rigid body out of it. And once that's done, you can see we now have two identical arch objects that are breaking the exact same way. Changing the physical properties using the material editor is really easy and gives us a couple of different results very quickly. So I'm going to just move this toolbar up over here. And I'm going to choose concrete as our first one. And we'll just go ahead and select the first object. And we're going to go ahead and assign that material to that selection. And I'm going to choose the other material. And we're just going to assign the rubber material to it. So we have identical objects, but two different physical materials. And we'll go ahead and press play, and we can see how different they react immediately. So it gives us kind of some variation that we need. Obviously, you probably wouldn't want to have the other one being rubber, but I just wanted to bring to your attention the different types of properties that are available to you. We can also create materials from scratch. So I'll say, create a physical material, and we have an unnamed material that has basically density, friction, and bounciness set to be the same. So we'll crank down the density, we will crank up the bounciness, and we will assign that to our currently selected object, and now it'll behave completely differently as well. You can see the other arch is really influencing it quite a bit. So creating PhysX simulations and adjusting the properties is really easy and fast, and will help bring a lot of variety to your simulations. Now let's take a look at another type of simulation called a ragdoll. So the last thing we're going to look at is putting together a quick ragdoll solution. I've pulled in some of the geometry from our opening shot, and you can see here we have the stairs, the arches, and we have a biped character standing at the top of the steps. So first thing I'm going to do is I'm going to select everything in the scene that I don't want to move. This is the same arch that we used before that's been all cut up, ready to be destroyed, but we're not going to do that here. We're just going to use that as a static object. So I'll go to PhysX and I'll get the toolbar. And from the PhysX toolbar, I'm going to choose to make all of these items static rigid bodies, which means that although they'll be part of the solution, they won't really move. The next thing I'm going to do is I'm going to choose the biped. Once I have the biped selected, I can say create kinematic ragdoll, and the ragdoll is already created. We just have to add the bones. So we'll come in here and we'll add the bones to the solution. We'll do dynamic joints, and we'll regenerate the entire biped. So now that we have the ragdoll solution applied, we can just press play to quickly begin to see the solution. Obviously, we don't have time to tweak it up in the short amount of time that we have to take a look at it here, but we're able to get some ragdoll physics going in our scene that we can bake out to animation. In addition to any of these types of constraints, we have additional constraints that can be used for more complex types of solutions. Rigid constraint slides, hinges, twists, ball and socket. So quite a diverse set of solutions. So, with PhysX, we can really create a wider range of realistic dynamic simulations than we were able to before. 3ds Max 2011 and 3ds Max Design 2011 deliver a whole new way to think about materials with the introduction of Substance. Substance is a new smart map type that supports procedural materials called substances, created by Algorithmic's Substance Designer application. This is the object that we're going to be using to create our substance material for. So I'm just going to go ahead and open up my Slate Material Editor. And I already have a basic Arch and Design material created that we're going to use to create our substance-based material. So to invoke the substance material, all I'm going to do is right-click in my view, and I'm going to choose Maps, Standard, and I choose the new map type called Substance that appears in the list. We immediately get a substance node, and to use the substance, all we have to do is double-click on it to get to the Properties dialog box, and you can see we can click and browse. From here, we're taken to the list of substance textures that are available for us to use. There's basically two types. There's noises, which are grayscale materials like broken glass, caustics, dirt clods, electric bolts, things like that, things that can be used as masks or other types of displacements on other materials. In the second category, textures, we have over 60 new substance materials that are available for us to use directly within the substance map type. So first thing I'm going to do is I'm going to go find our marble material, and I'm just going to bring that up. As soon as we bring the substance material into the node, you can see a couple of things happen. We have a lot of output nodes from a single map. This is really advantageous because this gives us the ability to, with one map, take advantage of things like a diffuse, specular, normal, bump, displacement, all generated on the fly from a single map. So to hook up a substance, very easy to do. It's just like any other map. We choose our diffuse channel, and that immediately creates a diffuse channel, and you can see that our texture is already applied on our material. We can go ahead and apply a specular glossiness if we want to. If we're using a normal map, we'd still want to introduce the normal bump channel to control the direction, but same procedure. We just drop in our normal map, and we'll go ahead and put that into our bump map slot. We also have the ability to have displacement maps or height maps. In this case, we won't be using either of those. Now that we have it created, we can actually take a look at some of the parameters within here. First and foremost, you can see that we have the parameters of the substance. Each substance has its own set of parameters that are defined when the substance is created in the Algorithmic Substance Designer application. Now, we have the ability to control all kinds of formations within the marble itself. Asperities, if we want to increase damage, we can go ahead and crank up the damage amount. So, we can see that it gives us kind of a damage look to it. We can increase or decrease the swirls or the depth. The relief balance, we can just set this to be, any number. And it gives us all kinds of parametric control over what the material is actually doing. We can also adjust the saturation if we want to, or reduce it. Really lots of different controls here. We'll bring that back down. And you can see it gives us a lot of flexibility in what it is that we're doing with our materials. Once we have the parameters set up, we also have control over texture size. Now, initially, the texture is generated at a 512 by 512 resolution. We can go ahead and lock the aspect ratio, and we can set it to be anything that we want to be. And what this does is it regenerates the texture on the fly and displays it within the viewport. So we'll get a higher quality texture that's available to be seen directly within the viewport. Then additionally, we have the ability to control what happens to the texture at render time. So for example, we can choose to change the local settings, meaning that we can multiply it based off of whatever this number is. So we can keep our global texture size relatively small, but increase it or decrease it as we need to based on how we're going to be using it. So you have a lot of control over the texture size and the procedural nature. Of course, we also have the ability to do some basic tiling. So we'll just go ahead and add in a tile of 2 here. And you can see that the texture automatically updates within the scene. Just from one substance, we're able to populate several map slots on one material for quick and versatile editing of our materials. Incorporating substances into complex materials is just as easy. I've created a more complex material already based off of the substance material that we've just created. So you can see here's our substance map with the marble texture that we've already done. Here is our source map. Here's our normal bump and our specular, just like we had before. We're doing a couple of different things. We're kind of grunging this map up a little bit, and what I've done is I've incorporated several different map types. We're using a composite map to combine an ambient occlusion map, which you can see here, that I've made using render surface. Using another substance, I've created another piece of grunge. This is also be a displacement map. And I've piped them all into our arch and design material. So if I choose this, I'll go ahead and select the object and I'll assign the material to selection. And you can see that once it comes up, we have a really grungy looking texture that has a lot of relief in it, has some displacement, is using both substance materials and standard bitmaps, and it gives you a really excellent look and feel to the material. Additionally, I've created a second material using a substance. Very simple. I'm using the grass substance, and I'm just taking out the diffuse and the bump channel. And we're going to use this to simulate moss or something growing up the side of these columns. I'm also using a mask here to blend between the two textures. So just using a blend material, I'll go ahead and pipe this in. I'll select our object. We'll go ahead and assign the material to the selection. And then once we render this out, we'll be able to see the effect that these two materials have together on our object. So let me go ahead and do that real quick. So here's our rendering, and you can see that it's a pretty good match for what we're seeing within the viewport. The displacement channels are showing up really nicely. The blended texture is showing up really good. So substance materials allow you to dial in numerous attributes for dynamic, flexible, and virtually endless variations of materials and maps.
Thanks for watching and learning how the Subscription Advantage Pack for Autodesk 3ds Max and 3ds Max Design 2011 can make an impact on the work you do. If your Autodesk 3ds Max or 3ds Max Design software is on subscription, you can download your Subscription Advantage Pack now from within your 2011 product or download it from the Autodesk Subscription Center.